Welcome to NPTEL, a basic course on electric and magnetic circuits. We are in module 4 dealing with 3 phase circuits, and lecture 2 is on line and phase currents and voltages in a star connected system. So, let us go in details about the star connected system and what are the corresponding line voltages and currents. So, in the last lecture we talk about balance current and voltages. So, that we mean that magnitude should be same and 3 phases should be separated by 120 degree apart. If either in magnitude or in phase there are deviations, then we call them unbalanced. In our lectures on 3 phase here, we will be dealing only with the balance currents and balance voltages. So, we will talk about a star system here. So, let us say this is your star system. So, we have 3 impedances Z, Z and Z, they are being same. So, the corresponding from the balance supply, the corresponding current magnitude will also be same, and the angle between R phase, Y phase and B phase currents will be also magnitude same, angle will be 120 degree apart. So, let us the corresponding balance voltages is B p with 0 degree, B p with minus 120 degree and B p with minus 240 degree or plus 120 degree as you see. So, these are the corresponding V r, V y and V b phasors. So, this is about the phase voltages applied to this system here to the supply side. Now, you see here we are dealing with now line and phase. So, the corresponding current which flows in the line is I r here, the corresponding current which flows in the line is the line current. So, line I mean that the corresponding supply line or the corresponding supply cables, the current which flows in that R phase is I r current. So, that is about the line current. Now, what about the phase? So, phase here we mean phase here for your clarity, phase here equals to winding. So, winding here you mean the winding for the load like a fan load, a winding for the fan single phase, the corresponding load. Similarly, in the generation also the corresponding generator winding we consider. So, that phase winding. So, if I consider the corresponding this Z, the corresponding load of the Z, the impedance Z, the winding, then the corresponding current through this impedance or this corresponding winding equals to phase is nothing but the phase current. So, current through this impedance Z is nothing but the phase current, current through the line is nothing but the line current. That implies for a star connected system, the line current flowing in the line equals to the phase current flowing through the impedance Z or the corresponding winding, because they are connected in series here. So, if we apply the corresponding current law, then the corresponding I r becomes equals to the same as the current flowing to the impedance Z. So, we can straightforward say that the line current equals to phase current in a star connected system, or in phasor quantities the phase current line current becomes equals to phase current in phasor quantity also. Now, talking about the voltage. So, we talk about the line voltage versus the phase voltage. So, line voltage is nothing but the line to line voltage, because this line and this line are line corresponding to this R, line corresponding to the Y. So, a voltage between this is nothing but the line to line voltage, or simply I call line voltage, because voltage means between 2 points. So, we require this point and this point. So, this is nothing but the voltage between 2 lines and it is called the line voltage. Now, what about the phase voltage? As I said, phase equals to the concept of winding, phase equals to the impedance here. So, therefore, the voltage across the impedance, voltage across the winding, voltage across the winding or the impedance is called the phase voltage. So, once again line voltage between 2 lines, phase voltage, voltage across the winding, voltage across the impedance is the phase voltage. So, therefore, we see here that what happens here, the corresponding voltage line voltage versus the phase voltage relation. So, we see here the line to line voltage or the line voltage, the voltage between two lines. So, V R Y we call V R Y between R and Y phases. So, that becomes equals to V R minus V Y phasor in terms of, and that equals to, as already mentioned here, this is V R with reference phasor, this is V Y phasor. So, this V R Y equals to V R phasor minus V Y phasor. This is the convention we are using here. So, this V R phasor, V Y phasor minus, so we take it to minus V Y, this is minus V Y, summation of these two is nothing but the corresponding V R Y phasor. So, what I have taken here, this is V R phasor, this is V Y phasor. So, this is minus V Y, we take it to the reverse direction and then we add them to V R minus V Y. So, the resultant becomes V R Y. So, this is about the V R Y. So, what we see here, because in between them is 120 degree. So, this angle between this becomes 60 degree. So, the angle between V R Y and V R becomes 30 degree. So, straightforward to this the V R Y takes an angle plus 30 degree with respect to the V R. So, if V R equals to V P with 0 degree, then the V R Y equals to with a certain magnitude with angle plus 30 degree leading by 30 degree. Now, what is the magnitude perspective? Because this is about V R and V Y and angle between them is 60 degree. So, the phasor additions here straightforward here, if we substitute this V P 0 degree and V P minus 120 degree here, then we got the V P to be 1 plus half plus j 0.866 phasor addition of these two, that leads to this V P 3 by 2 plus j root 3 by 2 and that gives you root 3 V P with an angle of 30 degree. So, what we see here, then the corresponding magnitude comes out to be root 3 V P R. So, this also from the phasor also same magnitude of V R, same magnitude of V Y, angle between them 60 degree, resultant phasor takes root 3 V P. The magnitude of the resultant phasor line voltage, that becomes equals to root 3 V P. So, the V R Y comes out to be equals to root 3 V P 30 degree as compared to the V R phasor, that equals to V P with an angle of 0 degree. So, what we see that the V R Y leads the V R by 30 degree and its magnitude is root 3 times that of the V R phasor. So, that is the conclusion we get from the what we mean by the line voltage versus the phase voltage. Line voltage here we have analyzed is V R Y and the phase voltage we are talking about is V R and V Y, and these are balanced, and then as compared to the corresponding V R phasor, the V R Y phasor which is happens to be V R minus V Y phasor happens to be leading the V R by 30 degree and a magnitude of root 3 times that of the phase voltage V R. So, that is the straightforward relation we get for the in terms for the voltages for a star connected load. Now, we will have more on this. Let us go by this for the next one is this is V Y B. V Y B is V Y minus V B, V Y minus V B. So, we will see what is V Y minus V B. This is V R, this is V Y, this is V B. So, V Y minus V B. So, we will draw the V B minus V B here and resultant of these two will be this direction. So, this is V Y B. So, if we plot here this is V R. So, now we got this is V Y, this is V B. So, then we have minus of V B here. So, this V R and V Y and minus V B add, then we got these two phasor to be V Y B. So, therefore, here also like that earlier this is 60 degree. So, then the corresponding V Y B phasor leads the corresponding V Y phasor by 30 degree. So, conclusion is that V Y B leads the V Y phasor by 30 degree, and then if we go by this corresponding addition of V Y and minus V B, we get this to be also root 3 V P minus of 90 degree from the phasor addition. So, what we say that the voltage magnitude is of the line voltage, that is V Y B, happens to be root 3 times the phase voltage and it leads the corresponding V Y phasor by 30 degree. Similar conclusion what we got for the earlier for the V R Y case also. Now, similarly, for the VBR, VBR equals to VB minus VR, VBR equals to VB minus VR. So, minus VR means this direction, this is minus VR. So, resultant of these two will be getting in terms of this. So, this is minus VR. So, this and this. So, we get the corresponding, this becomes equals to VBR phasor. So, VBR phasor will be, VBR phasor leads the VB phasor by 30 degree, this is your 30 degree case. So, and then the corresponding line voltages magnitude becomes equals to root 3 times the phase voltage. So, in conclusion, for the three phase voltages VR, Vp with an angle of 0 degree, Vy with Vp minus 120 degree, Vb with Vp minus 240 degree, then the corresponding line voltages becomes equals to root 3 Vp 30 degree for Vry, Vyb equals to root 3 Vp minus 90 degree and Vbr equals to root 3 Vp minus 210 degree from the above analysis. So, we say that this voltage leads Vr, first letter Vr by 30 degree, Vyb the first letter Vy leads Vy by 30 degree, Vbr first letter is Vb leads Vb by 30 degree. So, straightforward conclusion from this. So, that is the case. So, if we can know the Vr, Vy, Vb, we can straightforward conclude that what will happen to the corresponding Vr, Vry, Vyb, Vbr. So, the series is Ryb sequence and then we are talking about the corresponding line voltages to be what we have addressed here is Vry, Vyb and Vbr, Ry, Yb, Br, Ry, Yb, Br. So, that is the corresponding sequence we talk about and if we maintain that sequence, the corresponding voltages lead the corresponding R by 30 degree, Y by 30 degree and B by 30 degree respectively. So, this is the corresponding relations for phase voltage versus line voltage relation and already we have seen that line current equals to phase current, we have already seen for the star connected system. So, in overall for a star connected load systems with phase voltages Vr, Vy, Vb expressed at 0 degree, minus 120 degree and plus 120 degree, the corresponding phase voltages Ry, Yb and Br 30, minus 90, minus 210. So, I can show them in terms of the phasor Vr, Vy and Vb phasors, then the corresponding Ry, Yb and Br phasors take the position like this. So, this is about the x axis 30 degree here and this is about the By, the corresponding phasors you can say that they maintain to be 30 degree in terms of that. So, that is the corresponding maintained angle in terms of that perspective and so. So, this will be taking a position of to be in terms of the 90 degree perspective and so. Now, what we say here that the corresponding line current becomes equals to the corresponding phase current also in terms of that. So, another thing we want to notice here that the magnitude of the line voltage becomes equals to root 3 times that of the phase voltage and so. So, that is the for a phase sequence of RYB we can do like this and if the corresponding phase sequence becomes ABC, we can say that BA, BB and BC, then the corresponding line voltages we can take out AB, BBC and BCA. These are the all phasors for that. Moving forward, for the star connected system, we say that the corresponding IP voltage that becomes equals to Vp by Zp. So, what we say that we know that the corresponding IP, the corresponding IR current here, let us say that IR current becomes equals to the VR voltage by the corresponding Zp or the Z impedance. So, from there we can generalize that for a star connected system, the phase current or the line currents they are same, that becomes equals to the phase voltage upon the corresponding impedance. So, therefore, for each phase whether it is R, whether it is Y or whether it is B phase, then we say that the corresponding Vp phasor Vp connect the corresponding Zp the impedance star impedance, then the corresponding IP becomes equals to this. So, that IP becomes equals to Vp by Zp. However, for a star connected system, line current equals to phase current and the line voltage equals to root 3 by V p also. So, therefore, 3 phase system here can be for a star connected system can be analyzed in terms of a single phase systems with the phase voltage and the corresponding star impedance connected as shown here. Now, a 3 phase connections to our building, if you see from the star connected load or whatever connections we have. So, this is let us say 400 volt 50 Hz 3 phase systems R, Y, B and the N, the neutral. So, then the corresponding phase considered connections you can take from the any of the phase, that is R and N. So, this becomes in a star connected system, because we say as already mentioned in terms of that if a star connected systems we have like this 3 impedances Z, Z and Z, and then we have this star point, this is connected to the neutral and neutral wire. So, this is also Z. So, if you see that the corresponding voltage line voltage is here between two lines and phase voltage is here. So, unless and otherwise mentioned, the voltage mentioned in the 3 phase system is line voltage, unless otherwise mentioned the voltage in 3 phase system mentioned is line voltage. So, this 400 volt here is line to line voltage or simply line voltage of the V line. So, therefore, in phase voltage for a star connected system as shown here, the corresponding phase voltage becomes equals to 400 by root 3. So, this is V p in this case. So, this comes out to be 400 by root 3 very close to 231 volt or so. So, what we say here that if our house is connected from the 3 phase supply system with a one phase and one neutral, then out of the 400 volt we are getting 400 by root 3 volt. And if the corresponding supply system is a 3 phase supply system to any induction motor or any pump house or so, then only 3 wires are connected and they are having 400 volt 3 phase 3 wire connection itself. So, that is the different connection arrangement. So, for the 3 phase 4 wire connection for a building or house or any system and so. So, once again that unless and otherwise mentioned, the corresponding voltage mentioned in a 3 phase system is line voltages between two lines. Now, let us go by a few examples for our clarity. So, first example is on a star connected system. Here the star connected 3 phase load having R 1 is having 100 ohm. So, it is a resistive load, purely resistance only, no reactance part, is connected to a balanced voltage supply of 173.2 volt 50 Hz system. The phase sequence is ABC, phase sequence is ABC. So, by that we understand first A, then B, then C. Considering phase A voltage as reference, it means that V A will be a reference with magnitude with 0 degree. Calculate all line currents, calculate all line currents, current in the line, this is I A, this is I C and this is I B. So, this is are the 3 currents. Draw phasors showing all line currents and line voltages. So, we will plot the corresponding phasors for all line voltages and line current. So, what we see here, this is supply voltage is 173.2 volt 50 Hz. So, as I said, this is about the line voltage. So, this is line voltage. So, for a 3 phase star connected system, the phase voltage that becomes equals to 173.2 divided by root 3. So, this gives us 100 volt straight forward. So, the phase voltage becomes 100 volt. Now, as per the data given here, information given here, phase A voltage reference. So, we say that the phase A voltage V A that comes out to be 100 in magnitude with angle of 0 degree voltage. So, this is V A and the phase sequence is A, B, C. So, next comes B phase. So, that will be lagging to this B, B, that will be lagging to the corresponding by 120 degree, and then comes the C which will be lagging to the B phase by 120 degree or this side also 120 degree. So, this is about the corresponding phasor position about the V A, V B, V C as per the data information given. Now, with phase A this. Now, we will go for this corresponding I A current. I A current will be equals to the corresponding V A voltage, phase voltage across this will be 100 with an angle of 0 degree, this is V A phasor. So, therefore, V A divided by the corresponding impedance here is nothing but a resistance of 100 ohm. So, Z equals to nothing but a 100 with an angle of 0 degree. So, this is 100 with an angle of 0 degree V A. So, this becomes equals to 100 with an angle of 0 degree divided by 100 with an angle of 0 degree, that gives us 1 with an angle of 0 degree ampere for I A phasor. This I A is nothing but line current and same as the phase current, because current through the R 1 will be also the same current if we see from apply from KCL at the node A in this case. Similarly, once you know the corresponding, because the system is balanced, all are having R 1 and R 1 impedances. So, the corresponding current will be also balanced. So, therefore, the current also happens to be there. If I A is the corresponding reference current, then the corresponding I B current will be 120 degree apart, this is 0 degree, then the corresponding I C current will be also 120 degree apart to each other. So, that means that as I A is happens to be 1 with 0 degree, 1 with a 0 degree, I B 1 with an angle of minus 120 degree and I C will be 1 with an angle of minus 240 degree ampere case. So, that is why we got the corresponding line currents, and the line voltages as you see here is nothing but V A B, that becomes equals to V A minus V B, and we know the corresponding V A and V B and B C. So, we substitute the value of this. So, then we will get the corresponding V A B, V B C and B C A. So, once you got the corresponding V A B, then as we know B C will be lagging to A B by 120 degree and C A will be lagging to the B B C by 120 degree, as we have already analyzed earlier from the phasor diagram. So, let us go by this corresponding solution. So, V A equals to 100 by 0 degree, 173.2 by root 3. So, that is we already mentioned. Then I A becomes equals to V A divided by the Z, Z is here 100 with a 0 degree because resistive only. So, that gives us 1 with an angle of 0 ampere. So, this is about the line current, and line current equals to same as the phase current here, line current equals to phase current here. Now, V B equals to here 100 with an angle of 120 degree with respect to V A, and V C happens to be 100 with an angle of minus 240 degree. So, the corresponding I B equals to V B upon Z. So, that gives you I to be the corresponding I B to be 1 with an angle of minus 120 degree and I C equals to 1 with an angle of minus 240 degree. So, therefore, this I A, I B, I C happens to be the corresponding current in terms of that. Now, you go by this V A B, the corresponding line voltage V A minus V B. So, if you substitute that 100 with 0 degree and minus 100 with minus 120 degree voltage, then I got this from the phasor addition, I got this to be equals to 100 with root 3 with 30 degree. So, then I got it to be on 173.2 with a 30 degree. So, what we saw here that the line voltage is root 3 times the phase voltage, true, and then that becomes 173.2 as already data given, and then the angle of this V A B is 30 degree leading to V A, that is 0 degree by 30 degree leading. So, that also we have already concluded from our earlier discussion. So, therefore, if this is V A, then the V B you can say that is root 3 times of V A and leading the corresponding this by 30 degree. So, that is the phasor position of V A and V B. Now, we say that this is V B. So, now the corresponding V B C will be leading the corresponding V B by 30 degree and then B C A leading the corresponding B C divided by 2 by 30 degree. So, that is the corresponding different position of B B C and B C also. You can calculate from the B B C equals to B B minus B C and also B C A equals to B C minus B A also. So, that also you can find the corresponding phasor position also there. But as I already said, because the corresponding sequence is A B C. So, we say that B A B, B B C and B C A they go by the corresponding 120 degree separations to each other. That also you can straightforward conclude, because this is a balanced supply voltage system. On the current perspective, because it is a resistive circuit, V A and I A they are in phase. So, I A with 1 with an angle of 0 degree, then the I B also in phase with B B and I C also in phase with B C. So, then the corresponding I A, I B, I C position also happens to be like that, and as already said line current equals to phase current. So, we have the same I A, I B, I C happens to be there. So, this figure is nothing but gives you the complete picture for phase voltages, line currents and phase currents for the resistive circuit, star connected resistive circuit. Go to the next second example. In a balanced 3-phase circuit, the voltage VAB is given to us, VAB, and the phase sequence here is ABC. So, small letter here all, VAB equals to 173.2 with an angle of 0 degree volt. Determine all voltages phase and line and currents phase and line. So, because this is star, we say that phase current I A equals to the line current I A equals to the phase current I A, same. So, star connected load with Z 1 having equals to 10 with angle of 20 degree. So, that shows that the phi is positive, it implies that this is a RL load. So, the current will be lagging to the voltage by 20 degree. Phase current will be lagging to the phase voltage by 20 degree. So, consider the phase sequence to be ABC. So, for this case, similar to the earlier one, we got this to be Z to be equals to 10 with an angle of 20 degree ohm. So, now you need to the corresponding, to find the corresponding phase current, we need to the phase voltage VA. So, if we see here the line voltage VAB is having 0 degree. So, phase voltage to this phase voltage, the line voltage VAB leads by 30 degree. So, then therefore, the VA becomes equals to, in terms of magnitude, 173.2 divided by root 3 phase voltage divided by root 3, and the angle will be 0 minus of 30 degree. So, that is the straightforward conclusion from this. So, then the position of VA is known now. So, therefore, from IA phase voltage here, IA becomes equals to VA upon the corresponding impedance Z. So, we can get the corresponding IA. So, once you know the IA, because this is a balanced system, we can know IB to be 120 degree lagging to IA and IC to be 120 degree lagging to IB. So, that way you can get the corresponding phasor position of IA, IB, IC, and we know that the line current equals to phase current for star system. Now, the corresponding VA is known, VAB is known, means VBC will be lagging the VAB by 120 degree, and to VCA it will be lagging, further VCA will be lagging to VBC by 120 degree, because phase sequence is AB. So, we go by AB, BC, CA, VAB, VBC, BCA. So, these three phasors lag each other by 120 degree, and then from the VA you got the corresponding VB, BC, BCA. So, we go by the solutions. VAB equals to 173 0 degree. So, VAN equals to 173 by root 3 with minus 30 degree, as I tell that to AB the VA lags by 30 degree, BBC 173.2 with minus 120 degree, it lags the VAB, and VCA equals to 173.2 minus 240 degree. VBN to A phase it lags by 120 degree, and to C it lags, the C lags VBN by 120 degree. So, we got these phase voltages, we got the line voltages, current phases VA equals to VA upon Z1. So, that becomes equals to 10 with minus 50 degree. So, once you get this 10 minus 170 and 10 minus 290 degree, that is what the corresponding currents, both phase and line currents. So, this is about the phase voltage, line voltage and phase current and line currents. Next example. So, we have an impedance of 8 minus J10. So, this is a RC case, negative X RC case. For the given 3 phase systems, find IA, IB, IC with a phase voltage as a reference. So, it means that VA will be having reference 1. So, that is the data given. So, then now the supply voltage is 400. So, this is the line voltage. So, phase voltage becomes equals to, magnitude becomes equals to 400 by root 3. So, this is the voltage. So, therefore, VA becomes equals to 400 by root 3 with an angle of 0 degree. So, this is about VA phase. So, therefore, because the sequence is VA ABC, then the corresponding VB and BC can be obtained straightforward from there. Now, for IA current, so this becomes equals to VA, voltage here is VA, phase voltage. So, VA divided by the corresponding impedance, impedance is 8 minus j 10. So, this gives us V A. Once we know the I A, then we can get the I B to be 120 degree apart and I C to be 120 degree apart. So, I got this V A to be equals to 400 by root 3 with 0 degree because it is a reference. Then the Z is nothing but 8 minus j 10. So, this is 12.81 minus 51.34 degree. Phi is negative, straightforward you can conclude that this is R C. So, current will be leading the voltage with certain angle. So, I A becomes equals to V A by Z A, V A by Z, V A by Z. So, that becomes equals to current becomes equals to 18.03 with 51.34. So, we saw that current is leading the voltage by 51.34 degree. I B then happens to be minus 120 degree lagging. So, 51.34 minus 120 gives you minus 68.66 and then I C lags the corresponding current by further 120 degree. So, that you can get by this, or you can find by this V B by Z or V C by Z formula also. So, these are the three currents I A, I B, I C for the capacitive load in this case. The next example, in the figure we have a capacitive load 6 minus j 8 each impedance. The load is supplied from a 3 phase balanced voltage source and the phase sequence is A B C. If the phase A current is 10 with 0 degree ampere, find V B N and V A B. Question is find V B and V A B. Current given is I A current equals to 10 with an angle of 0 degree. So, the impedance here is Z. So, Z equals to here is 6 minus j 8 ohm. So, this I A into Z gives us the corresponding V A. Let us say V A equals to I A into the corresponding Z. So, we got the V A phasor. Now, V B phasor or V B N phasor will be lagging the corresponding V A phasor by 120 degree. So, we got the V B. V A B equals to V A minus V B. So, from V A and V B we can get the corresponding V A B also. Otherwise, because the phase sequence is A B C, so we can say that to this V A, the V A B will be leading by 30 degree and with a magnitude root 3 times that of V A. So, that is the corresponding star connected for the star connected system. So, looking into the answer, so the V A N becomes equals to, as I said, current into the corresponding impedance, this impedance. So, that we got to be equals to 100 with an angle of minus 53.13, V B N lagging to this by minus 120 degrees. So, we got to be 100 with minus 173.13. These are the phase voltages. Line voltage V A B equals to phase voltage V A minus the V B. So, that gives us to be line voltage equals to V A B 100 into root 3 173.2 and the current the angle here you see here to this current leading this you can say that phi voltage of the V N to by 30 degree minus 53.13 plus 30 gives us minus 23.13 degree. So, that is the corresponding relation which we have already seen. We will go about another example for the line for the 3 phase systems balance voltage supply 190.5 volt with phase sequence as A B C, 190.5 volt as the line voltage and phase sequence is A B C. Line impedance Z L is 10 plus J 4, line impedance Z L is 10.J4 ohm and the line impedance is the corresponding load impedance here. The load impedance is Z load equals to the load impedance is 10 plus J 4 and the line impedance is Z I equals to 5 plus J 2. So, this is 5 plus J 2 ohm and the load impedance is 10 plus J 4 ohm, 10 plus J 4 ohm. The question is calculate the line current phasors considering V A as reference. So, V A becomes equals to the corresponding magnitude with an angle of 0 degree. Magnitude will be 190.5 divided by root 3 because this is star connected system. Voltage across here will be line voltage divided by root 3. Now, to the line current we have I A, that becomes equals to, we say here the voltage which is being supplied, balance voltage supply is this. So, this voltage here, this becomes equals to 190.5 divided by root 3. So, if you see this, go by this phase analysis. So, the corresponding from this to this, if you connect this, then as you say, if you connect this to this loop, then this path will be like this. So, for this case V A here, V A is 190.5 divided by root 3. So, V A 190 by 5.3, 190.5 by root 3 with 0 degree, this voltage divided by this sum of the impedances. So, this becomes equals to line impedance plus the load impedance ZL. So, the line impedance is 5 plus J2 plus 10 plus J4, the load impedance. So, this is the total impedance in this path. So, the corresponding current becomes equals to 190.5 divided by root 3 divided by this corresponding sum of the impedances. So, that nothing but this corresponding I A. So, the I A once you know, because this is a balanced system, we can find out I B, we can find out I C also 120 lagging to each other. So, if you go by that, the corresponding calculations, I A becomes equals to V A divided by ZL plus ZLI, V A divided by this corresponding ZLI plus the ZL for the each one. We connect like this, we have already analyzed earlier also for a such a system. Then this becomes equals to 6.81 with an angle of minus 21.8. So, I B becomes equals to 120 degree lagging to this, and I C becomes equals to 120 degree lagging to this perspective. So, we saw a star connected system having star impedance and line impedance, how you can analyze the corresponding circuit by considering a loop here KVL here. So, in overall this we discuss here about the star connected load, and we learn the corresponding concept of line and phase currents and line and phase voltages and the corresponding relations for the star connected system. Line current equals to phase current and line voltage equals to root 3 times phase voltage, and we see the also the corresponding the phase angle relations between line voltages and phase voltages, and for different sequences like A B C, R O I B and so. Thank you.